This is an overview of how the second version of the sequential switch I built within the ER-301 works. There are two main components, or two types of components. The first is what I'll refer to as the switch control, and the second is what I'll refer to as the switch step. We'll take a look at the switch control first. I've set this up as a global chain because it will be sent to the individual switch steps, and we want to ensure that they are all synchronized and receiving the same control signal. It consists of a mixer, an offset, and a quantizer. Inside the mixer on the left is where you insert the control signal. This might be an offset knob from another module. It could be an external LFO or step sequencer, or it could also be an internal unit or chain. The mixer and offset here are for conditioning the signal. The sequential switch is expecting voltages in the range of 0 to 10 volts. If your signal is bipolar, you can attenuate it and offset it using these tools so that it meets those requirements. The quantizer has two functions. First, it converts a continuous voltage into a discrete one with 4 possible levels. Second, with the post control, it attenuates the signal so that it has a minimum of 0 volts and a maximum of 3 volts. Essentially, it transforms your 0 to 10 volt input into a step signal that is either 0, 1, 2, or 3 volts. So if you feed a unipolar 0 to 10 volt sine wave into it, the output is going to look something like this. You really shouldn't need to make any adjustments to the quantizer, but you should condition your input signal with the mixer and offset before it, if it doesn't meet the 0 to 10 volt criteria. That's about it for the switch control. The rest of the magic happens inside the switch steps, so let's take a look at those. Each of the switch steps is contained in a mixer unit. Here they're shown left to right in a chain, and this is a great configuration if, for example, you had 4 audio signals that you wanted to switch between. It's also possible to move them elsewhere, which I'll demonstrate in another video. The goal here is to have each mixer pass the signal being fed into it with unity gain when the sequence control voltage says it should. So 0 volts for mixer 1, 1 volt for mixer 2, and so on. To accomplish this, we'll patch in some rational VCAs. These VCAs are acting as switches, either on, passing signal, or off, shunting signal. I've color-coded these VCAs green, and I'm going to refer to them as pull-up VCAs. This is because they're normally closed, and the control voltage will open them. Each of the pull-up VCA's numerators is fed with the switch control signal output from the global chain, the component we just covered a minute ago. By setting the right combination of numerator and divisor for each pull-up VCA, and also setting the right gain and bias for the numerator's input signal, we can accomplish just this. At 0 volts, the first VCA is at unity gain. At 1 volt, the second VCA is at unity gain. At 2 volts, the third VCA is at unity gain. And at 3 volts, the fourth VCA is at unity gain. So, what are the magic numbers? Here are the ones that work for me and are included in the patch. I'm not going to try to explain the math in this video, just the concept. So, we have a bit of a problem at this point. The pull-up VCAs are opening to pass a unity gain signal at the correct control voltage for each switch step. But by the time we reach 3 volts, all of the VCAs are open and letting their input signal through. So we're getting all 4 of the switch steps outputs at once. That's not what we want. Even worse, at a 3 volt control signal, some of the VCAs have gone above unity gain and are likely to clip on a strong input signal. So what do? I've heard some modular experts say that you can never have enough VCAs. So let's add some more VCAs. Luckily with the ER-301 we're not going to run out of them. I've color-coded the second set of VCAs in red, and I'm going to refer to them as pulled-down VCAs. Unlike the pull-up VCAs, they're designed to normally pass signal through at 0 volts. They're normally open. And by feeding them the same control signal and setting them with negative gains, we can cause them to close and let no signal through at the specific voltage level that they should. So essentially these pull-down VCAs will be chasing the pull-up VCAs to close any switch steps that should not be passing the signal. At 1 volt, we want the first pull-down VCA to close and mute the output of switch step 1. At 2 volts, we want the second pull-down VCA to close to mute the output of switch step 2. And at 3 volts, we want the third pull-down VCA to close to mute the output of switch step 3. So what about the fourth step? Well, you probably remember that its pull-up VCA only passes signal when our sequence control CV reaches 3 volts. So it really doesn't need a pull-down VCA. You might also remember when we were looking at the pull-up VCAs that the first switch step was passing at 0 volts, 1 volt, 2, and 3 volts. So actually there's no need for its pull-up VCA. It's always on, and its pull-down VCA is sufficient. So let's eliminate those two VCAs and look at the values for the pull-down VCAs. And this is what the patch looks like. For the sake of clarity, let's walk through what happens at each voltage output from the global switch control chain. At 0 volts, none of the VCAs have been activated. Step 1 is passing signal applied to its mixer with unity gain. The other steps are not letting any signal through because their pull-up VCAs have not been activated. At 1 volt, the pull-down VCA for step 1 has been activated. It mutes the signal coming from step 1. At the same time, the pull-up VCA for step 2 has been activated. So the signal in step 2 is now allowed to pass through with unity gain. Steps 3 and 4 remain silenced. At 2 volts, the pull-down VCA for step 2 engages, muting the output for the second step. And the pull-up VCA for step 3 is activated, allowing its signal to pass through. At 3 volts, the pull-down VCA for step 3 engages and shunts its output. The pull-up VCA for the fourth switch step is activated and passes its signal. It's not really necessary to know this to use the sequential switch, but I thought many would be interested in how it works and that it might not be apparent just from examining the patch. All right, let's take a quick look at the files that I've included in this distribution and kind of how to use them. So starting at the bottom here, I've got a Quicksave. This is just kind of something I threw together. It's actually a C7 chord audio rate oscillators that are being modulated by or switched by an internal sine wave. So it's just kind of a starting point if you want to jump in and have something that's just kind of already set up and working with this sequential switch. I haven't tested this yet, but my theory is that if you take the couple of files that are contained within this folder and drop them into one of the empty slot folders in your Quicksaves folder on your SD card, that would correspond to that Quicksave that you could load up. I would appreciate it if anybody could let me know if that actually works. The rest of the files, you can save them anywhere on your SD card structure that makes sense to you. I've just, personally kind of created a folder called Sequential Switch and thrown all these files into there. Let's look at the second file, the global chain. So I've kind of tried to label these as what kind of presets they are. The second one is the global chain. So it's actually a chain. It's intended for you to go into the master mode, admin mode, and load a global chain preset. So that's the control function or the timing function. The first file, chain all switches, is another chain type preset, and that's intended to go on a channel, and that's all four mixers just kind of back to back or in a sequence, just like we saw in the video. So that would be useful for like switching between audio files. The remaining files here, mixer step 1 through 4, are just the individual steps, so that you can place them anywhere you want. If you don't want to put them, in a sequence on a chain, for example, maybe you want to use them to modulate a bunch of different parameters, all throughout your patch. So that's the quick overview of those, and yeah, I think that's it. Okay, well, that was exhausting. So let's start to have some fun with this thing. The first thing I want to do is to show you this Quicksave. Hopefully you're able to load this up on your device if you want to. But I basically just wanted to show you what it does so that you know what to expect. So for me it's slot 3. I'll go ahead and hit load and load that one up. And here on my, I'm on the admin mode. So if I go in here and take a look at this thing. We've got a global chain set up here that this has the step control function, so the input, the offset, and the quantize. And here the input is just an internal sine wave that's being generated by a sine oscillator running at a pretty slow rate. And if I switch up to the user channel, you can see that that's driving these different steps as it goes across. So I've got these are on track 1, and I've got this routed to my audio output, and it's basically just a C7 chord being modulated by that sine wave. So here's what it sounds like. Okay, so for the next experiment here, I'm again starting with this Quicksave that just has the audio rate sine oscillators being switched between. But what I'm actually going to do here, you can kind of see I've moved my audio interface off. I'm now monitoring chain 2, which doesn't have anything on it right now, I don't think. But what we're going to do is actually use this sequential switch to go in here and use some internal units to create a complex CV kind of LFO source. So what I'll do, I'm going to go into step 1 here, and let's see, we've got a sine oscillator on here. You can kind of see it's at an audio rate, so I'm just going to go ahead and stick with a sine for this one, and what I'll do is I'm going to slow it way down. I don't know, it's maybe a good guess is where to start. Alright, so that's going to be our step 1. I'm going to drill down into step 2 now, and let's see here. Let's actually replace this one with something else. Let's take let's delete the sine oscillator, and let's insert another unit here, and let's go for the aliasing triangle. And again, we'll kind of keep this at a kind of an LFO kind of rate. Don't know what it's going to be yet, but hey, let's maybe take the level on that down a bit so that it's still positive. I guess we won't invert it, but maybe make it just a bit smaller in amplitude. So that'll be our step 2. Let's see here for step 3. Let's maybe go into this one and let's go. We'll delete that and insert. Let's see. Let's do the saw for this one, and again, kind of an LFO right here. And maybe we'll bring that one's level up just a touch. And then finally for step 4, we'll delete this sine wave oscillator. And what could we do with this? Let's try the skewed sine envelope, just because, well, it's there, and don't know that I've used it before. So let's give this a let's see here. How long of a duration? Let's go about that. Let's maybe just take a look at what this looks like. I don't know if this thing has to be triggered or how this works. I don't actually think I've used it before. Maybe this was a bad choice. Maybe this actually needs to be triggered by something. Let's put a sine wave in here to try to trigger it. And let's see. Let's also get this going at more of an LFO rate, and see if we've got any output over here. Oh yeah, we do. Hey, cool. Well, look at that. The skewed sine envelope. What happens if we skew that? Let's skew it in a negative direction. Oh, cool. Now it's making kind of a looks like more of a stronger exponential on the front end of it. So pretty neat. All right, so we've got 4 different inputs set up, one on each step, and let's just kind of, oh yeah, cool. So if you take a look at that, that is making kind of a cool, complex wave shape there. All right, so let's go down to channel 2, and let's see. I think just so we don't, let's just put some noise here. So let's listen to some white noise. Make sure that's making sound here. Oh yeah, beautiful. Okay, and let's come over here and we'll insert another unit, and let's insert. Let's do a ladder filter. And that sounds like this. So let's take our ladder filter's cutoff frequency, and let's use our complex LFO that we generated up on channel 1 to control this. Oh, no, it doesn't look like we can do it there, so let's go to we can use the volt proctive input. So let's go here, and we have that complex O set up on channel 1. So we can actually take that output, that digital output from channel 1, and we can route it here. So let's try to do that. And we'll come up, and oh wow, we got a crazy amount of modulation there. Let's hear what that sounds like. Cool, so should be able to go back up into the admin area. And let's see here, I've got the sine wave modulating it, so I should be able to kind of speed it up and slow it down here. Let's try that. Cool. So that is one possible application for the sequential switch, is creating kind of a crazy complex LFO within the ER-301. So for my last trick here, I kind of wanted to show you how to pretty much start from scratch, and also take these different switch steps, and rather than kind of lining them all up and using them to switch between volumes of different audio files or something like that, I wanted to actually take these steps and assign them to modulate different parameters and switch between them. So just to kind of get things started here, I've got a sample player set up on channel 1, and I've just got kind of an acoustic guitar loop playing through it, so that's what this sounds like. Alright, so let's set this puppy up. I'm going to start by going into the admin area, and it's kind of important to add this switch control first, and it's also important to name it, so let's do that. I'm going to go ahead and add a chain here, and we'll do a new mono chain. So it's apparently important for the mixer steps that I'm going to add, because they're expecting a modulation source with the specific name 1 to 4. And if it's not called that, it's not going to be able to sort of find what it needs to find. So as you go in here to load this, let's just make sure that we name it 1-4, just like that, for steps 1 to 4. So I'll press enter, commit that, and we'll go down into the chain, and I'm going to load a chain, and we'll navigate up. I've actually got these presets in my presets directory, and then I've got kind of a folder here called Sequential Switch set up. So if I go in here, we'll navigate down, and what I want to do here is load this global chain preset, the switch control. So we'll go ahead and fire that up. And you can see we've already got some output on here. I believe I still have this sine wave set up on here. So, yep, we've got an internal sine wave oscillator sort of driving it. And looks like it's already been, I've already got the offset and the mixer settings set up to make it fluctuate between 0 and 10 volts. So that will be just fine for this experiment. Taking a look at the quantized output, and we do get kind of a stepped signal from 1 to 4. All right, so let's go in and try to do something interesting here. I'm gonna confess I don't exactly have a great experiment in mind here. I'm gonna do something that you can hear, so that you can just kind of see how to set this up. And I'm gonna throw the gauntlet down here, and your challenge, should you choose to accept it, would be show me how to do something cool with this. So. Anyway, that is that's our global chain preset. One other thing I'm going to do in here is I'm going to set up a single modulation source in here to use this. I'm going to switch switch parameters that I'm modulating, but I'm going to use the same CV. So while I'm still here in the admin area, I'm going to do a new mono chain, and I'm just going to name this sine. I'm going to put a sine wave here, and that way I can just kind of reuse this as all the step inputs. So we'll drill down in here, and I'm going to insert a new unit, and we'll do the sine oscillator, and I'm going to bring this down to, kind of an LFO rate. Sure, that looks good, and we'll just leave it at 0.5 for the level, and that should be good for that one. So now we've got, just a sine wave LFO up here on our global chain. So coming back down here into the user area, what I actually want to do is start modulating some parameters here with the different steps. So let's see, I think maybe a good first choice of a place to start would be the, let's modulate the speed. So I'm going to come in here, and yeah, looks like I've already got my mixer channel loaded. Let me just delete this so we can kind of start fresh here. So back up, we're on the speed parameter. We're going to set its modulation source, and I'm going to come in here and I'm going to insert a mixer channel. And we'll come in here and I'm going to load a preset, and let's see here, we're going to navigate back up to the folder wherever you happen to have these stored, and I'll drill down in, and I want to pick this mixer step 1. So that should be the first step. I'll come in here and I'll load that up. And let's take a look in here. So you can see it's already kind of firing, but I don't have any input set up here. So what I actually want to do is choose that sine wave global chain that I set up. So I come back in here into globals, and let's just grab this sine wave. So now I've got my my modulation source set up here. And let's see here, we will come back up one more level. And I just kind of want to set some gain here. So it's already, looks like I tried this experiment before and ran into a little trouble. So let's bring it up, I don't know, maybe 0.78 so that we get something. So if I turn this up, what we should hear is the speed being modulated every time it hits step 1. So that's what that sounds like. So let's do something else here. I'm going to, let's see, maybe come over here and let me add a linear VCA onto the end of this. So we will do, let's see, where's my linear VCA at? Here it is. And let's go ahead and bring this level up to, I don't know, maybe 7.2. And what I want to do is actually modulate my volume now. So we'll come in here. I'm going to add a new mixer channel. And what I want to do here is load a preset. And this time I want to pick the second step. So we'll go back up to the sequential switch folder, drill down in, and I'll pick mixer step 2. And then we need to come down in here and we need to set an input source here. And I'm going to use that same sine wave that I have set up on the global chain. So we'll go to globals and I'll pick the sine wave. And I'm just going to come up one level here and I'm going to set the gain amount here. So let's roll this up a bit. Yeah, maybe quite a bit. Let's try to get a good effect out of it. And maybe let's bring the offset down, the bias just a little bit more and maybe start it there. All right, I'm going to turn the volume back up and let's see what we've got. All right, I'm really mangling this acoustic guitar loop for your viewing pleasure. Let's do one more thing here. So I'm not going to set up all 4 steps. Let's just do one more. So let's, you know what? Let's modulate the the volt per octave with step 3. So let's try to do some linear FM here. So I'm going to go in here, and within here we will insert a mixer channel, and I'm going to load a preset and navigate back up to my sequential switch folder, and let's pick step 3. So there's our step 3, and we'll come in here, and you know what, there's no law that says that I have to use the same input source for all of these. So rather than picking my global sine wave LFO, I'm going to insert a new unit here, and let me pick a sine oscillator. But let's bring this up to an audio rate. So let's actually get some linear FM going, and boy, we're really gonna decimate this this audio clip that I have going here. So I don't know, we'll just start at 427 hertz. And then all we need to do, well, actually this is the VO, so it looks like there's not even really an opportunity to set gain here. But if I did want to kind of control how much this was happening, because I've got this set up in a mixer channel, I could just kind of come down here and roll the gain down. So if I drill back up, we should, well, now we don't see it moving at all. Maybe I hit it a little too hard there. Let's bring this back up to, I don't know, maybe minus 13. So now we just see it moving a little bit. All right, so let's bring the volume back up. And just so we can hear what's going on a little more clearly, let me go back up to go down to the admin channel. And let's drill into our 1 to 4, our control source here. And I'm going to come back over here to my input, which is the sine wave. And let's roll its frequency down, you know, quite a bit, so that we can kind of hear the distinct steps that are going on here. So turn the volume back up. So there you have it, some crazy stuff. Wow. So like I say, if you have some cool ideas for how you might use this to you know, route your modulation source to various parameters, and you know, actually come up with something that sounds cool, I would love to see that. Anyway, thanks for watching. Hope you enjoyed, and hope you enjoy the sequential switch.